No mai haere mai to the final lesson on evaluating statistical graphs, the shape of the graph. In this one, we're going to talk about common causes for skew in a graph are outliers and clusters. We know that outliers are data points that are far apart from the rest of the data. And clusters are data points that are grouped close together. So looking at this set of data, any clusters, a couple 18s, a bunch of 19s, a couple 20s, and then a 58. Well, these values of 18 to 20 are considered to be a cluster. And this one value well away from the rest, that's an outlier. And outliers can affect our measures of central tendency and spread, especially the mean and the range. We said that the mean is affected by those outliers, and specifically, the mean pulls the median, or rather, the outlier pulls the mean in that direction. Please make sure this is in your notes. The outlier can pull the value of the mean towards it. An outlier much smaller than the rest of the data can lower the mean. An outlier much larger than the rest of the data can increase the mean. Notice how the effect of an outlier is similar to the effect of skew on the mean. Now, because an outlier is a piece of data that is far away from the rest of our data, it can increase the range of that data set. Again, good bit to add to your notes here. The following table summarizes the possible effects on measures of center and spread when an outlier is present. So an outlier can pull on the mean. It'll pull it in the direction where the outlier is. A really small outlier pulls the mean smaller. A really big outlier pulls the mean bigger. Where the median's the one in the middle, not usually affected by an outlier. The mode is the one that occurs most frequently, usually not affected by an outlier, where the range can definitely be affected by an outlier. Now, outliers and clusters are easily identifiable in graphs, especially with large data sets. Let's describe the shape of the graph below in terms of outliers and clusters. Well, this is well away from the rest. There's an outlier. We could say that in here is a cluster from 0 to 5 years is the age of the pets, and we could say there is another cluster. All right, so outliers well away from the rest, or a big grouping, that would be our cluster. So now is going to be some patai for you to try. Let's just go ahead and summarize what we've talked about in this lesson. We've examined what can affect the shape of our graph and how these things affect our measure of central tendency and spread. And the measures of central tendency, mean, median, and mode, and range is our spread, and the spread or the range is the distance from the smallest to the largest. We talked about a single mode being unimodal, two modes being bimodal, and more than two modes multimodal. We talked about a tail going to the left being negative skew. Both sides of the graph look roughly the same, like a peak mountain. That's a symmetrical data set. And if the data tails off to the right, that is positive skew. We talked about outliers and clusters. And that brings us to the end of this lesson on the information the shape of a graph provides. We're now able to use graphs to identify the shape of our data and possible influences on our measures of central tendency and spread. Thanks for watching. Kia pai te rā, kia koe, mauri mahi, mauri ora, ka kite anō.